Alright, so now we're going to take a look at some of these special cases. Okay, the first special case we're going to look at is where we have a binomial squared. And really we could apply this to any polynomial when you square it, at least the first part here. The idea is that when you square something, you're multiplying it by itself, right? 5 squared is 5 times 5, or 25 squared is 25 times 25. Whatever you're squaring is multiplied by itself. And so you could think of this as x plus 7 times x plus 7. Right? That is essentially what we're doing. Now, when you multiply, you want to make sure every term on the left multiplies every term on the right. So we distribute x times x is x squared. X times 7 is 7x. Then we have 7 times x is 7x also. And 7 times 7 is 49. Okay, so that gives us 4 terms. And the 2 in the middle will add up, because they're like terms, to 14x. Okay? And so essentially, we've got 3 terms now. And what I want you to notice is that there's a bit of a pattern to this. Notice that the x shows up in 2 of the terms, right? You've got your x squared and your x. Your 7 actually shows up kind of in 2 of the terms as well. You've got your 49, which is 7 squared, and you've got 14, which is 2 times the 7, okay? And so what ends up happening is the 2 terms in the original binomial can get squared on the ends, x squared and 49, and then you take in the middle, double their product. So if you multiplied 7 times x and doubled it, you'd get 14x, okay? And that's what happens when you add those 2 terms together. They're going to be the same term anytime you're squaring something, okay? As a general formula for this, and this pattern will happen every time. So let me show you a general formula, and then we'll apply it quickly to some other examples. So the general formula is this. If you have a plus b squared, so again a binomial squared, and I'll go through the steps before I show you the formula. You would just have a plus b times itself, because that's what squaring something does, and then you go ahead and distribute. Make sure every term on the left multiplies every term on the right. You'll end up with a squared, ab, another ab, and a b squared. Okay? And when you combine the like terms in the middle, you'll get 2ab, right? 2 of the same thing. So this is a squared plus 2ab plus b squared. Again, notice that just if you wanted to skip all the work in the middle and jump right to the end, you just take the first term, square it, take the second term, square it on the other end, and in the middle, you do double their product. You multiply them together and multiply by 2, okay? That should give you a nice short formula for doing this anytime you square a binomial. All right, so take a quick example. This time I'm not going to go through all these steps in the middle, even though that's where this comes from. Instead, I'm just going to use the formula going straight to the answer, okay? So let's take an example of x plus 3 squared, okay? Well, using this pattern, then you're going to square the first term. Then on the outside, on the far side, you're going to square the other term. So I've got x squared and I've got 9. But now in the middle, I need to have double their product, or else I'm going to have it wrong. I'm going to be missing a term. Okay? The product is 3x. If I double that, I get 6x. Okay? So 6x goes in the middle. And I can repeat this again anytime, and it doesn't have to just have an x in the front. I could have other things there. So I could have something like 4x minus 6 all squared, okay? Again, I take the first term and square it. 4x squared is 16x squared, right? So if I take that first term and square it, I square the 4, I get 16, I square the x, and I get x squared. Then I take this 6 and square it. Actually, I take the minus 6. I could take the whole thing. But if you square a negative, you still get a positive. So it doesn't matter. I'm just going to have a positive at the end. So it's plus 6 squared is 36. Okay. So again, the square of a negative is positive. But then I want the product in the middle times 2, right? Double the product. So if I take 4x and negative 6, that's a negative 24x. I double that, I get negative 48x. So I get minus 48x in the middle, okay? So 16x squared minus 48x plus 32 is going to be all of the necessary terms to square that binomial, okay? There is a temptation, and it's a wrong temptation, to simply square the two terms and bring them down. Okay, you would be then missing that middle term, and that's going to be an important middle term, okay, an important term. So make sure to be very careful and patient with these problems, and to either utilize this formula to do it quickly, or you could multiply it by itself and go through and do all the distributing. It doesn't matter to me which one you use. Obviously the formula would get you there faster, but if you don't trust yourself to use the formula or to do it correctly, you can go through this process of distributing. It's a longer process, takes a few extra seconds, maybe 10-15 extra seconds per problem, but it is also accurate, so you can use either one. Okay, so that's the first special form. There's a couple more. Of course, there is a variation to this that I should show you as well, which kind of comes up in this problem here when you have a subtraction instead of an addition. So if you had a subtraction there instead, then these two terms both change to subtractions. In the next line, the two middle terms are negative, but this last term you have a negative times a negative, which would stay positive, so I don't change that one. And then in the final formula, the first term is negative, so actually the second term. So first term's positive, second term's negative, third term's positive. Okay, so it does change just one sign. So the negative, if it's a minus b, you end up with a minus 2ab instead of a plus 2ab. That's the only difference in the formula. Okay. Okay, so that gives you really two formulas, essentially. Now, let's look at one other special case. I think it's the only other one we'll deal with. I'm just going to double check. Yep. Okay, so the other special case is where you have a binomial, like x plus 4, and something called its conjugate, x minus 4. Now, the idea of a conjugate is a binomial, a pair of binomials, where the middle sign or the middle operation is different. One's a sum and one's a difference, okay? So conjugates, they have the same two terms except for the sign in the middle. So you have things like a plus b and a minus b. Those are conjugates, okay? Any two terms that are the same, one has a plus in the middle, one has a minus in the middle, they're considered conjugates. When you multiply conjugates together, something very nice happens, okay? So I'll go through and show you this. Multiply the x's, you get x squared. The outer you get a minus 4x. The inner here you get a plus 4x. and then on the end you get a minus 16, okay? Notice in the middle here when I combine the like terms, I have a minus 4x plus 4x, they add up to 0. So those actually cancel out, and I'm left with just x squared minus 16, okay? This is a difference of two squares. It's the two original terms squared with a subtraction in between, okay? We call this a difference of squares. This will occur every time you multiply conjugates. You essentially lose that middle term, and you end up with only two terms, and they're both the squares, okay? So in general, when you multiply two conjugates, and I could go through and show you the work on this, but I'll skip that for right now, you end up with the first term squared minus the second term squared. And so, just sort of as a shortcut, again, we can apply that to any general binomial. So if I take, for instance, let's go with y minus 8 and y plus 8, okay? Those are conjugates again. And so instead of going through and distributing and combining like terms, it may be simpler to follow this pattern. Just take the first term squared, take the second term squared, because they are conjugates, and put a subtraction in between them. And you're done, okay? So this is what you would get if you went through and did all the distributing and combining like terms, but this is just quite a bit faster, okay? Same answer though. And of course we can do this with more complicated binomials. Let's do something like 10x squared minus 8x times 10x squared plus 8x. Okay, so these are definitely a little bit more complicated, but again, they're just conjugates, right? I've got the 10x squared in both, and I've got the 8x in both, but one's got the plus, one's got the minus, so they're conjugates. Again, to find their product, rather than doing all the distributing and adding your powers and then combining like terms, we can just simply square each term and put a minus between it. So the first term, when I square it, I'm going to get 100x to the fourth. Squaring a term doubles the power. So that becomes 100x to the fourth. 8x becomes 64x squared. And then I just have a minus in between, okay? So again, the minus, you'll always have in these a minus in between them, okay? All right, and now I have a difference of two squares. You can see these two terms are obviously squares. 164 are both numerical squares. X to the fourth and x squared are both squares of variables, okay? And so, so that gives you a pretty good idea of both of the special formulas that we'll see when we're multiplying polynomials.